So today we're going to continue on with this prerequisite chapter, still section 5. This is day 2 of it, so P5B will be the homework you're looking for. And today we're going to learn how to multiply and divide rational expressions. So what we're going to be doing when we're multiplying and dividing is you're going to need to factor each part of the fraction. Then when we multiply, after it's been factored, we're going to look for things to cancel from the numerator and the denominator. Now you can either cancel top to bottom or across, so diagonal. You cannot cancel left to right or side to side. So you can't cancel a numerator with a numerator or a denominator with a denominator. You always have to find a match from the numerator with a denominator of one of the fractions. When we divide, we're going to stay, change, flip, or keep, change, flip. Whatever you learned how to divide fractions, maybe back in 4th grade, where we're going to keep the first fraction the same, change the division sign to multiplication, and then flip the second fraction upside down or to its reciprocal. So let's go ahead and try some examples. All right, the first example is multiplication. So what I need to do here is I need to factor. There's only one thing, luckily in this one, that needs to be factored, and it's going to be the numerator of this second fraction. So this second fraction, that numerator is the difference of two perfect squares. So for multiplication, you're going to keep the first fraction, you're going to keep them in the same orientation. You're not flipping anything for multiplication. So the first fraction was good, nothing to factor. However, the top of that second fraction, difference of two squares, so x plus 3, x minus 3, and then the denominator stays the same, x plus 4. So now I'm looking for exact matches, something that is in the numerator, and I'm going to look for an exact match in the denominator. So here I have an x plus 3 here, and then over here diagonally. So now what remains is the x minus 2, x minus 3 in red there, over x plus 4. And you're done. You do not need to FOIL it. You're leaving it in factored form. Notice this one has the same thing that's looking to get factored. So again, all I need to factor is the top of that first fraction. And again, difference of two squares. So x minus 3, x plus 3. The order that you write that doesn't matter. The denominator, nothing to factor, so just write it down. Second fraction, nothing to factor there, so just write it. Now, if it helps you to put parentheses around these so that you know that they're grouped together, then now I'm going to look for my matches. So here I've got an x plus 3 on top of an x plus 3. That cancels. And then I also have an x minus 3 that I can cancel diagonally with this one. Now remember, when you're canceling these things, what remains after you cancel is a 1. Because essentially what you're doing is the same thing divided by the same thing, and anything divided by itself is 1. So now the only thing that remains is the x plus 4. The denominator is a 1, but when the denominator is a 1, your final answer is just that numerator. So the final answer here is x plus 4. Oh boy, now we got 4 problems we got to factor. So let me go ahead and do each one individually. So over here, I'm going to factor this one. So I have 2x squared plus x minus 6. I'm going to go ahead and do my factor by grouping. You could guess and test if you choose, but remember we're going to multiply the beginning and the end. So I'm looking for the two numbers that'll multiply to give me negative 12, but who add to give me a 1. Now when that middle term is a 1 or a negative 1, that's a clue to me that my factors are going to be side by side. So my factors of 12, negative 12, that will give me a 1, that's going to be positive 4 and negative 3. Because the bigger factor gets the sign of the middle, and my middle was positive 1. So now I'm going to rewrite the first term, replace the middle, that positive x, with the two factors I just found. Doesn't matter the order you put them in. And now I have to factor by grouping. I'm going to make my two groups here. My greatest common factor of my first group is x. So then I'm going to divide. And then my GCF of the second group is going to be a 2. Divide it. Notice what I have in common in the parentheses is the same. So I write it down and then take the two GCFs that you just divided by, becomes the next binomial. So now I have the numerator of that first fraction factored. So let me go ahead and write it over here. I'll write it over here. 2x minus 3, and then x plus 2. Now let me work on the denominator. This one's a simple one because the number in front of x squared is a 1. So I'm just looking for factors of negative 5 that will give me a positive 4, and that's going to be x plus 5, x minus 1. Remember, the sign of the middle goes on the larger factor. So that's already done. Let me go ahead and write that in the bottom. So x plus 5, x minus 1. Now I'm going to do the numerator of the second fraction. Notice at first you see it's an x cubed, so you might think, oh, the difference are sum of two cubes, but it's a trinomial. But notice they also have all in common an x. You should always look for a GCF first. So I'm going to divide all three terms by x, and then I'm left with x squared minus 3x plus 2. So I pulled out the GCF. So then now I need to find factors of 2 that will give me negative 3, and those factors are going to be negative 2 and negative 1. Notice I put that GCF in front. It doesn't disappear. So let me go ahead and now write that over here. So that's the factored form of that numerator. So x times x minus 2 and x minus 1. One last piece to factor. So I'll do that one in orange. So we have different colors here. Oh, that sort of looks like the red. Let me look for green. Let's see if will green show up good. Let's see. Yeah. All right, we'll do green. All right, so for this one, the 4x squared, let me do it up top here. 4x squared minus 6x, not really showing up. Let me do it in the blue.
Like a dark green.
Let's see if I can get a darker green. Doesn't really give me a dark green. How about purple? All right, let's do purple. Let's see, oh, it didn't take. I'll do it in black. 4x squared minus 6x. So I'm looking for a greatest common factor first. So my GCF here is going to be 2x. I'm going to divide it, 2x minus 3. So that'll go in the denominator now. So 2x minus 3. All right, so now that I have all four pieces factored, now I'm going to go back and look for things to simplify. So notice I've got a 2x minus 3 on the top and the bottom over here. So these are now gone. But again, remember what remains is going to be a 1. And then no x plus 2 to cancel. And then if I go to look for, notice I could cancel the x. So I can get rid of this x here and this x. So again, what remains behind here is a 1 and then this is just the 2. And then now I'm going to also see that I have an x minus 1 that I can cancel. And again, what remains is a 1. And now nothing else can be canceled. So the final answer here is going to be the x plus 2 and the x minus 2. And in the denominator, the x plus 5 times the 2. And you leave it in factored form. Do not distribute, do not FOIL it back. So for the next one, it's already in factored form. Let me go ahead and write the problem again. So it's a little bit bigger. So a 1, and then x minus 1, 25, x minus 2. All right, so again, I'm looking for things to simplify. Notice the x minus 1's cancel. And again, you're left behind with a 1. And then I can also simplify the 5 and the 25. So this would become a 1. This would become a 5. And now I'm going to multiply what remains. The numerator is 1 times 1. And then the denominator is just the 5 times the x minus 2. So it's going to be really important that you're writing neatly. And again, make sure that you can see what you're crossing out, what you're not, and then write clearly what's being left behind. All right, so again, factor first. So I need to factor this numerator. And again, it's nice and simple. I'm just looking for factors of -6 that will give me a -1. So those factors are going to be -3 and +2. So let me go ahead and write that over here. X minus 3, x plus 2. For the denominator, notice here I have a perfect square trinomial. Or you could do it the traditional way, factors of 9 that combine to give you 6. And those factors are going to be +3 and +3. The numerator of the second fraction, we do not need to factor. It's already factored. So let me just rewrite it. And then the denominator, the difference of 2 perfect squares. So I can factor that one. X minus 2 and x plus 2. So now I start to look for things that will simplify. So notice I've got an x minus 3. No, I do not. But I have an x plus 2 that I can cancel with over here. And then I also have an x plus 3 that I can cancel over here. Nothing else will cancel. So I have the red x minus 3 in the top. And then I have a blue and a purple one left behind in the denominator. And you're done. Now for the division problems, remember we're doing keep, change, flip, or stay, change, change. Now, before I even get involved in my factoring, I like to do the flip first, just in case I forget. So what I'm going to do first is I'm going to keep my first fraction the same. So the x cubed minus 8, x squared minus 4, change the division to multiplication, and flip the second fraction upside down to its reciprocal. Now, my process is exactly the same that I just did for the first 5 examples. I now have a multiplication equation or function, or actually expression, that I can now simplify by factoring each piece. Notice in my numerators, I've got in the first one the difference of 2 perfect cubes, and the second numerator is the sum of 2 cubes. So I need to do the soap pattern for those two numerators. So for the first one, let me go ahead and do this one in blue. So for the first one, it's x to the third minus 8. So I'm going to cube root. So remember, the pattern we're using here is u minus v, u squared, opposite sign, u times v plus v squared. Remember, the trinomial that results can never be factored any further. So I'm going to get my u value by finding the cube root of x to the third, and my v value is the cube root of 8. So my u is going to be x, and my v value is going to be 2. So when I factor this, I'm going to end up with x minus 2, x squared, now opposite sign, multiply the 2 and the x, and then square the 2. So that is that top numerator, the difference of two perfect cubes, factored. So x minus 2, then the trinomial, x squared plus 2x plus 4. And again, that trinomial, you cannot find factors of 4 that will give you 2. So you stop. The next one, the denominator, difference of two squares. So x minus 2, x plus 2. The numerator, the sum of two perfect cubes. So again, same soap pattern. However, the signs are going to be different because it's an addition. So for this one, the pattern will be u plus v, still u squared, opposite sign, uv plus v squared. So x cubed plus 8, we're going to get our u value by cube rooting x to the third, which gives you x, the v value, cube root 8, and you get 2. So now let's put it into the pattern. So x plus 2, square the x, opposite sign, multiply that u and v, and then the v squared. So that's my numerator. X plus 2, x squared minus 2x plus 4. The denominator, if you notice, it's that same blue trinomial we got. This cannot be factored. There are no factors of 4 that are going to give me 2 in the middle. So this one can't be factored, so I'm just rewriting it. So now I've got my fully factored expression, so now I look for things to simplify. So I have in the numerator an x minus 2, and in the denominator an x minus 2. So these are going to cancel, become 1s. Then diagonally, I have an x squared plus 2x plus 4. This will cancel with this denominator over here. So this one, let me do a different color. This one cancels with this one. Then now I have an x plus 2 and an x plus 2. So now the only thing that remains is that purple numerator, and the answer is x squared minus 2x plus 4 is your final answer. Again, remember, the trinomials from the factored cube cannot be factored any further. Next one. Still the difference of two perfect cubes here. So let's go ahead and factor this one. And again, I'm still using that soap pattern. So remember, we cube root x to the third, we get x. Cube root 1, we get 1. Then we're going to square that x, opposite sign. 1 times x is just x, and then square the 1. So that is the factored numerator. Let me write it over here. x minus 1, x squared plus x plus 1. Now let's work on the denominator. The denominator, difference of two perfect squares. So I'm just going to factor this one, x minus 1, x plus 1. Ooh, I forgot to flip first. Let me go back and do that because this is division. So let me rewrite this problem. So x cubed minus 1 over, you don't necessarily have to show this, but it's helpful because you may get, so involved in your factoring that you may forget that what you should have done is flipped it right from the beginning. So for the numerator now, factors of 1 that will give me 2. This is a perfect square trinomial. So the factors of 1 are going to be 1 times 1. And then when you add 1 plus 1, you get 2. So this numerator is going to factor into x plus 1 and x plus 1, a binomial squared. And instead of putting it to the second power, I'm going to write it out twice so it makes it easier for me when I go to cancel. Now the denominator though, notice on this one, there are no factors of 1 that will give me 1. So this one I can't factor, so let me just rewrite it. Now I'm going to look for things to simplify. So notice I've got an x minus 1 in the numerator here, and an x minus 1 in the denominator. These both become 1s. Then I also have a purple x squared plus x plus 1 that I can also cancel with this one in the denominator. And then I also can get rid of the x plus 1 in the numerator and in the denominator. So this one and this one also become 1s. And now what remains is just that blue x plus 1 from the numerator. All right, next one's still division. So again, I'm going to rewrite it as a multiplication. So keep, change, and flip. So x over x minus 1, keep that fraction the same. Change the division to multiplication, flip the fraction upside down. The only thing I need to factor here is the numerator of the second fraction, the x squared minus 1, the difference of two squares. So let me go ahead, and this one is okay. It stays the same. I'm going to factor the numerator into x plus 1, x minus 1, and then it still has the x squared in the bottom. Now, if it's easier for you to see that x squared is x times x, you can do that. So then now I look for things to simplify. I can get rid of one of the x's. I can also get rid of the x minus 1. So now what remains is the x plus 1 from the numerator over the x that's left in the denominator. And then one last division. And again, I am going to keep, change, flip it. So x squared minus 14x plus 49. X squared minus 49. Change it to multiplication, flip upside down. So now I begin my factoring process. Now, do not think that you can see this, oh, it's a 49, let me get rid of it. You have to factor. You can't just cancel numbers. So again, treat this as being grouped all together, and then we're going to look for things to factor. So the factors of 49, that will give me 14. This is actually a perfect square trinomial. If you do the check and you square root the ends and double it, it does give you the middle. So this one actually turns into a binomial squared when I factor it. So this will turn into x minus 7 times x minus 7. And then the denominator, the difference of two perfect squares, So this will factor into x minus 7 and x plus 7. The numerator of this second fraction, nothing to do. I'm just going to rewrite it. And then the denominator can be factored a GCF. I can divide both of those by 3. So this will factor into 3 times x minus 7. Now it's factored. Now go to look for things that will simplify. So I can simplify the x minus 7 with this x minus 7. And what's left behind is a 1. I can simplify this x plus 7 with this x plus 7. And again, what's left behind is a 1. And then I also have an x minus 7 that I can still simplify. This one with this one. And again, what's left behind are 1s. And now, the only thing that's left is that purple 3 and the 1 in the top. So my final answer here is 1/3.